Consider the natural numbers that are less than or equal to 15. I've written them out in case we need to do some crossing out or meditating on them before we go on. List the numbers that satisfy each of the following conditions. X is odd. Okay, so they want out of these numbers which ones are odd. 1, 3, 5, blah, 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 13, 15. Pretty easy so far. X is prime. Okay. A prime number is one that has no factors other than itself and 1. Now, sometimes they say that 1 is not a prime number and they concoct elaborate reasons why it isn't. I think it is. If you see other books that say it isn't, well, believe who you want. It doesn't come up all that often. 2 is a prime number. It's only divisible by itself and 1. Sometimes people will argue that 2 isn't a prime number because no even number is a prime number. That's not good thinking. That's following a rule that works for every other even number, but it isn't true for 2. 3 is prime. 5 is prime. 6 is divisible by 2 and 3. 7 is prime. 8 is 2 times 4. 9 is 3 times 3. 10 is 5 times 2. 11 is prime. 12 is 2 times 6. 13 is prime. 14 is 2 times 7, and 15 is 5 times 3. So there's our list of primes from 1 up to 13. Now, X is odd and X is prime. Sure enough, I thought I could get away with shortcutting that list, and I shouldn't have, so one moment while I get caught up. Here's a proper list. 7, 9, 11, 13, 15. Okay. And means both of these things have to be true at the same time. In other words, for and, we're looking for numbers that are on the odds list and that are also on the primes list. So 1 is on both lists. 1 is odd and also prime. In my opinion, if 1 isn't on the list of solutions someplace else, then fine, that's somebody who believes that 1 isn't a prime number. I don't want to get into it any further. 3 is odd and prime. 5 is odd and also prime. 7 is odd and also prime. 9 is odd but not prime, so that one doesn't count. You have to be both of these things to qualify for group C. 9 is odd, sorry, just did that, odd but not prime. 11 is odd and prime. 13 is odd and prime. 15 is odd but not prime. So there's our list. When they say and, it's got to be something that appears in both categories. Now, if X is odd or prime, or means either one of these is all right. It's what we call an inclusive or, meaning it can be this, or it can be this, or it could be both. That's fine. So 1 is odd and also prime. 3 is odd and also prime. 5 is odd and also prime. 7 is odd and prime. 9 is only odd, but that's okay. It's an either or, so just being odd is enough. Same with 11, 13, 15. X is a factor of 3 or 5 or 7. Okay, well, let's get a list here. The factors of 3 would be 1 and 3. The factors of 5 are 1 and 5. The factors of 7 are 1 and 7. So if any one of these is enough, because they said or, then our complete list would be 1, 3, 5, and 7. Now they do it again, but they say and. So we're looking at this same group of numbers, factors of 3, factors of 5, factors of 7, but now they want a number that's a factor of 3 and a factor of 5 and a factor of 7. Well, there's only one number that's all of those things at once. 1 is the only number that's a factor of 3 and also of 5 and also of 7. So and means you've got to hit all of the requirements, or means just hit any one requirement and you're good. Now, if X is a multiple of 3 or 5 or 7, the multiples of 3 are 3, 6, 9, 12, 15, etc. The multiples of 5 are 5, 10, 15, etc. The multiples of 7 are 7, 14, etc. I'm just sticking with numbers that are 15 or less. So if you're a multiple of 3 or 5 or 7, that means any one of these is enough. So we'd get a list that goes 3, 5, 6, 7, 9, 10, 12, trying to keep these in order, 14, 15, that should be all of them. If you appear on any one of these lists, then you're in. Now, for H, they switch to AND. Now they want a number that's on this list, and also on this list, and also on this list, and guess what? There aren't any. 7 is a multiple of 7, but it isn't a multiple of either of the other guys. 14 is a multiple of 7, but isn't a multiple of either of the others, and so here there are no numbers that satisfy all these conditions at once. In logic, we sometimes use a 0 with a slash through it like this to mean the empty set, which is a way of saying there aren't any things that meet all of these requirements. You're asking too much here.